As a data scientist, oftentimes you'll have to go through the following steps in machine learning. So the first step is data collection. If you're participating in a competition like Kaggle, most times your data set will be already selected. Or maybe in this video, you already have a chosen data set. But if you're in the industry, you might need to source for those data sets, or maybe you'll be given, depending on your problem domain. Second step here is data preparation, data prep. Most times here, you're dealing with, you want to find the missing values, outliers, duplicates. Sometimes you'll have features that have both numeric and categorical data. You might need to perform one hot encoding, just to change those categorical data sets or features. Okay. In some cases, you might have features that have different scales. You might need to normalize that using different, maybe min-max or z-score. And of course, perform additional feature engineering steps to remove some of those biases. Third step, you might need to select a model. Again, this depends on your data. Some models might be complex, others might be simple. Again, next you need to train your model, using the model.fit. Here you just want to fit your model to detect patterns, relationships in your training data. And then the fifth step here is to evaluate your model, right? Again, here you want to use the validation set to assess how well your training model performs on unseen data. And then most times you want to perform hyperparameter tuning, right? In this case, again, you want to tune different parameters in your model or in your classifier or algorithm to see whether you can improve the performance or get better performance. And lastly, once you have your final model, you want to generate the prediction. All right. However, in this video, we're going to go through regression analysis. Regression analysis is just a supervised learning technique where the goal is to predict a continuous value. Again, that's your target or outcome variable based on one or more input variables or features. Sometimes we call this independent variables, right? Here, you're training your model using label data set where your input variables and your target or output variables are known. In regression analysis, we fit a regression algorithm, right? This algorithm just fits a mathematical equation between your inputs and outputs in the training data, so as to make predictions on the unseen data. Okay. Again, regression analysis is widely used in many real-world applications, such as predicting the price of a house, which in this video, we're going to go through that, or stock prices. So the first step is to import. I've already run some of these codes. So here we just import some of the basic libraries, pandas here, to import our data set using the read .read_CSV, convert our data into a data frame. For computation, this too is for visualization. And then here we import our algorithms. Again, we can do this at the beginning, or you can import this library as and when it's needed, as you continue to selecting your model here. So again, you can see we have linear regression, k-neighbors. One thing you'll notice here, when you're performing regression analysis from sklearn package or library, most times you see the regressor here, or regression, meaning this algorithm is used for regression. Okay, SVR here comes from SVM, but again, here with the regression R. Then again, here, the standard scaler here, just applying z-score here, we're just subtracting the mean and scaling it with unit variance. Train test split for data splitting. The metrics here, we import the metrics. In regression analysis, we're going to be paying attention to R squared, RMSE, and mean absolute error. And then again, cross validation, how well we want to assess our model using cross validation. And then again, for fine tuning or hyperparameter tuning, there's also a technique called grid search, where it will automatically select some of the optimal parameters, and then you come again and fit it in your model and see whether it's going to improve or get better performance. Again, you can download the dataset from here. Again, you can see you can copy it in your Google Drive. So if you go here, make sure you click on this to mount your drive, and then folder like this will appear in your drive. You can create a folder and save this inside there, right? So again, it's the same thing as, so if I just, I could just use the sample data set here. Again, see, if you copy here, it's gonna be temporary, right? Meaning it's as good as when your session is on. And once you have that, it's the same thing as just coming here, this vertical dots, copy path. So if I do that, you can see just tells us it's in content USA.csv. That's the same thing you're gonna do here. Anyway, so here we're just gonna be loading and calling our data set, USA_housing. Again, we use the pandas to do that. Access this for reading.csv, files.csv. So second step here is data prep. So most times through EDA, exploratory data analysis will help us to identify if there are any issues in our data set. So first thing is to check the first 5 observations. So we're gonna use the pandas.header here. So we call this entire row a training example or observation. As you can see, it's complete record of all these columns, including the price. Okay. So again, we can use the info. Info again just confirms that this is a data frame. Our object here is a data frame. Okay, class type. You can see here we have the following columns, 6 of them. We don't have any missing values. So we have a total of 5,000 observations, and the data type here is float. Again, we can use this columns method to extract all the columns, right? You can see here it's just a string. It's an index of all the strings, just to quickly see how many columns we have. So for this one, luckily or fortunately, it kind of fits in our screen, but most times you'll have very long table. Okay. So describe here just allows us to view the summary statistics. So as you can see here, the count here is we have 5,000 observations. So you can see here for, let's see, area population. So for example, here you can see the minimum here. Let's see here what we have here. Yeah, so the maximum here, you can see we have a total population of 69,621. Okay, and a minimum population, I think, of 1,726. And the minimum population here is 36,199. So that's how to quickly, glean some information out of this. Same with the price here. You can see the most expensive house is at $246,906. Okay, minimum here, I think, should be 15,000. Or rather, let's see, 15,938. Okay, and the mean average here is right about $123,266. Okay, so that's how to look into that. Again, here, this is just to allow us to check if there's any missing values. So again, here, there are no missing values. So here is null is just to check, do we have any rows that have, or columns that have, is null, like missing values. So that's 0. Again, we can use this method to find the correlation, right? So the correlation here, just to see, so any column here correlated with itself is 1, right? A positive number just tells you how much correlation you have. But again, using this table might be a bit difficult to see. But you can see here, price and income, again, there's a positive correlation, right, between average income and price. So that means an increase in income also results in an increase in the price of a house. That's how probably to look into that. Okay. When we have negative correlation, there isn't much correlation between those two. All right. In our case here, average area income and area population. But let's just quickly visualize this. We kind of use the seaborn here. We use the pair plot, just allows us to generate a pairwise relationship, and then we pass our data frame. So right off the bat, we can see there's something going on here. There's a linear trend between price and area population. That means usually there's a correlation here, linear trend, right? An increase in population tends to result in an increase in price, most probably because of the demand for housing. So just creates that pressure, right? Similarly here, we can see number of rooms too, as well with the price. Again here, house age, again, that no surprises here. A house should be an asset, right? So the longer the older the house, sometimes the higher the price, So yeah, then income as well, we've already looked at that. So that's how just to look at that. Others like this one, very hard to tell. So this is what pair plot would quickly help you to just look at the trend analysis. We can also use the histogram. Again, histogram here also just tells us the skewness in data, right? So this is a small data set, but again, we can see here area house of the age is fairly normalized, right? Again, nothing much there. Most of our data sets here, most of our columns here look a bit normalized. You can see area population, majority at 35,000 here. Again, the price of a house, remember we looked at that around 123,000. So again, that's how to look into that. The average number of rooms looks like between 6 and 7. Here there's a bit of skewness, right? Skewness, again here we have this average area income. So you can see majority of the population, the income is just about here, right? Maybe 70,000. Okay. So that's how to detect, if we have right skewed or left skewed, right? Just helps us to determine where the biases are. Okay. Again, here we can use a displot where we use it for univariate distribution to visualize the distribution of our univariate feature, in our case here, price, right? So just say use this plot to view this column price from our housing data set, data frame. And you can see the distribution of price based on this plot. It's just you can see here, it's just almost like a histogram, right? But it just shows you distribution of one feature in our case here. That's why we call it univariate. Again, we can use this plot here to just answer the question, what's the average number of rooms? Again, you can see here, based on that distribution, you can see it's almost about here. Okay. So visualization is a great tool just to quickly look at, different features, right? Then here we can also use a scatter plot to quickly look at the average area number of rooms, right? And we're saying here we're getting this from the housing data set, and want to compare, two continuous variable. X-axis is the average area number of bedrooms, and Y-axis is the price, right? So it just shows you a scatter plot, right? Again, you can see here average number of rooms. It's very hard to tell, but based on price, I don't know, the number of average rooms looks like there's almost like a linear trend. There's majority average room based on price is almost here and here, right? Anyways, so again, we can also do another, again, here we can now see a linear trend using scatter plot. That's the goal here. But because here we have different categories, that's how it looks like this. So it's hard to tell. But when we have a linear trend, clearly here, an increase in income, most times you will see that the price of the house goes up, and probably depends on another maybe factor, the area population, right? All right, again, we can see here this plot for area population, majority of the population around here, right? And so on and so forth. So again, we can see that all this just allows us to visualize, our data and find, if there are any biases, any issues that we need to go further and perform some additional data prep. And lastly here, we can also see the relationship between average area income and area population. So we use the scatter plot from Seaborn. Our x-axis would be average area income from this data set, data frame, and then y-axis, here we just explicitly mention that. You could just say y equals to the area population. So area population will be our y. And then hue here just means we want to group this variable based on different colors using price. You can see the darker the dots here just tells you where the price is expensive. And you can see this is the legend, right? So the darker it is, that means we are approaching the 200,000 range. Again, that's just what it means. Okay. All right, and then lastly here, you can also check the relationship between different numeric variables. We can use a heat map. So first of all, we draw our figure. We want it to be of this size, 10:8, right? So again here, 8 columns, 10 rows. Again here, we want to use a heat map, and we pass our data set, and we want to remember the correlation here, the table. Then we're saying that we want to put the text of those values from our table. That's why we use a not true annotation. Then here we just give the theme. In our case here, the color map. Again, what we can see here is that there's some correlation between average income and price, 64% here, or 0.64. Again, we can also, there's a correlation here between price and house age, again, and maybe area population. So that's how to use the heat map. And you can see here, the darker the color, it just tells you if there's a correlation, with one being perfect correlation, what just means that the feature is correlated with one another. So price and price. So that's why it's just one. So the goal here is just look at, where the trends are. We've already looked at that based on trend analysis. All right. So that's just data preparation, just very useful, allows us to, detect if we have missing values, if we have outliers. We could even have used box plots here. Okay. Again, it just allows us to perform a little bit of feature engineering or feature selection, right? So as a data scientist, much of the time will be spent in data preparation, so that in our next step, we're going to be looking at model building.